Hello guys, I am Nidhishri S. Bagalwadi, Sankalp Learning Solutions, your science teacher. So in the last session, we learned regarding the refraction through spherical mirrors. We learned in detail regarding how the images will be formed through the spherical mirrors as well as types of spherical mirrors. Today we are going to discuss in detail regarding the reflecting surfaces which we are using in our daily life. I think you might see my spectacles. Okay, this I have because I can't see the far object so clearly, so I have this. Okay, so what is in it? So let me discuss now. So you all saw the watch repairer. Okay, he will be using a tiny piece of glass to repair the watch, right? Then you might see in your school libraries or in the city libraries that they will be having the magnifying lens, which we can see in our geometry board box also. So to see the small letters or to read the small letters clearly. So these glasses used by watch repairers as well as the spectacles. So these all are made up of one or two reflecting surfaces. So the materials which have one or two spherical reflecting surfaces are termed as lenses. So these lenses we can observe in microscope also. We can see in binoculars, or we can tell in a common language we will tell that it is a durbin. So which we will use to see the far objects. Right. So these are the daily things where we will use the lens. Okay, so let me clarify what is the definition of a lens. So here it is a transparent material. No doubt if a light has to be passed, the material should be transparent. And it is a transparent material which will be having one or two spherical surfaces. At least one is mandatory. The other one is if it is there or it is not there, it's okay. So a transparent material which has at least one or two spherical surfaces, the surfaces should be reflecting. Two reflecting surfaces are called as lens. Okay, so here we have types of lenses. So in the last sessions we learned regarding types of mirror, spherical mirror and the in spherical mirrors. So concave mirror and the convex mirror. Concave mirror means what? The reflecting surface will be bulged outside. Convex mirror, the reflecting surface will be bulged inside. So like that only here, if a lens has a two reflecting surfaces, two reflecting curved surfaces, then it is called as biconvex. If it has two reflecting surfaces which are curved, which are inside, so it is called biconcave. Biconvex, biconcave, or simply we can call them as convex lens or a concave lens. Then in some of the lenses, what happens, one surface will be curved and reflecting, the other surface will also be reflecting, but it will be plane, so it is called as plano convex. Same manner, one surface will be plane, the other surface will be inside. Okay, inside, so it is a plano concave. In some lenses, one side will be bulged outside, the other side will be bulged inside. So it can call it as concavo-convex, or we can call convexo-concave. So these are the basic types of lenses, right? So these lenses are used in our daily life. For example, if you have the nearsightedness, that is a myopia, so they will use the convex lens. If you have hypermetropia, you can't see the farer object, we can see the concave, we can use the concave lenses. Let us discuss about it in later classes. So here, now we are going to discuss how the light rays will be passed through these lenses. How the images will be formed. What is the condition? What will be the nature of the images? Right. Now, let us consider a convex lens. So, as we have two spherical surfaces, two spherical reflecting surfaces, we know that one spherical reflecting surfaces will be having center of curvature, pole, then radius of curvature, then focal length. This is for one spherical surfaces. So like that we have two spherical reflecting surfaces, so that we will be having two centers of curvature which are named as C1 and C2, focal length F1 and F2, radius of curvature R1 and R2. And here the aperture what we studied in the spherical mirror, here it is called as aperture of a lens and which is denoted by letter O. It is the center of the lens, letter O. Okay, now it is a letter O, then no doubt both the spherical surfaces will be part of the sphere. So they will be having center of curvature. So these are the distance between O and center of curvature will be radius of curvature. And where the images will be formed, those will be principal focus, right? And the line, an imaginary line which is passing through the center of a lens, that is O, and the center of curvatures is called as principal axis. So let us consider a parallel beam of light, a parallel rays of light are incident on the convex lens. So when these are incident, they will undergo the reflection, and all these rays, they will meet at certain point on the principal axis. So the point where they will meet is called as principal focus of a lens. Principal focus of a lens. Right? So as all the rays are meeting at a point, as all the rays are converging at a single point, this convex lens is also called as converging lens. Converging lens. Okay, so here the aperture, the whole diameter of the lens will be very less, is considered as very less, so that these situations might be explained. Okay, then the center of curvatures, that is C1 and C2. C1 and C2 will be equidistant for the situations which we will study in 10th standard. For that we have to consider that the aperture will be very small and the centers of curvature will be equidistant, will be at the same distance from the center of a lens. That is the condition. Then when we go to the concave lens, so when we pass a parallel rays of light, the rays of light found to be diverge or found to be spread after the reflection. So when we proceed, let me clear you, I think it is not dark. See. Okay. So these are the diverged or spreaded rays from the concave lens. Okay. Now when we proceed or when we draw an imaginary line through these diverged rays, they will appear, means these all rays appear to come from a point. So that point is called as principal focus of a concave lens. So principal focus of a concave lens is formed when the diverged rays are appear to meet from a point. So here what is happening? The light rays are diverging or spreading from a single point, whereas in convex lens the rays are meeting at a single point. So that is why the concave lens are referred as diverging lens. Converging lens is a convex lens, diverging lens is a concave lens. In the upcoming sessions, we are going to discuss in detail regarding how the images will be formed using these lenses. So today we learned regarding the definition of lenses, the types of lenses, and what will be the conditions of the rays of light when they are passed through the convex and the concave lenses. Until that, learn science, observe science. Have a nice day.